Hello everybody, so today we are starting the 8.4 day 1 notes. If you notice, this isn't really a note sheet, it's more of me rambling over the notes app. That's because I cut out quite a bit from the notes. I just want to teach you the important stuff, and this first page, the formatting got all goofy, and I just thought this would be the easiest way to kind of go through and teach you. But if you haven't noticed, at top it says, hey, you should have your perfects card out for this unit. If you don't have it out, or if you don't have one with you, I will either post a picture or find a link of one. I'm hoping to post a picture of the one that you're used to working with. If you don't have a physical copy, I would strongly suggest just saving that to your desktop, because we're going to be working with that a ton moving forward again. So a quick review. First of all, just what does 3 squared mean? Well, that's 3 times 3. You should know that's 9. 3 to the third, a common mistake is to do 3 times 3, but really it's 3 times 3 times 3, which is 27. Let me erase this and put it in blue so I'm kind of color-coded. 9, sorry. And then last, we would have 3 to the fourth is 3 times 3 times 3 times 3. 4 3's multiplied together, and we should get 81. Okay, so 3 to what power then would give us 30? Well, I don't know. It's not going to come out nice, though, because we know that 3 to the third is 27. And if we had a number line, 27 would be here. The next nice power of 3, we just said, was 81. So if this is a number line, where the heck would 30 fall? I don't know. Right there. So this was 3 to the third. This is 3 to the fourth. What the heck is going to go right here? Well, it's going to be a decimal, we know, but what is that decimal going to be? I don't know, maybe 3.1, 3 to the 3.1 power. That might be close. I'm not really sure. I have to use a calculator to guess. Kind of the point of that is we'll be using something called logarithms, or just short for logs, this chapter to figure problems like this out. You might remember from like the ACT practice, right before the ACT, I went over some logarithm problems. That's pretty much what we're doing today, just the very, very basics of them. Before we dive deeper into this, I do want to have a quick negative exponents review. So I'm talking right here. I kind of figured out that it's hard to tell what I'm talking about unless I box off each section. Okay, so as a review, remember, you cannot have a negative exponent. That's Sparta math or Joe Dirt math. We don't want that. So how do we get rid of a negative exponent? Well, if it's on the bottom, it goes to the top, and if it's on top, it goes to the bottom. So for example, 3 to the negative fourth becomes 1 over 3 to the positive 4. And we know, like we talked about in the beginning, that 3 to the positive 4 power is 81. So 3 to the negative 4 power is 81. Okay, kind of along the same lines, if I had 1 over 5 to the negative 2 power, my negative exponent goes to the top and becomes positive. This would be 5 squared over 1, which is just 25. Hopefully that's a review. If you want to pause the video quick and try these 3 example problems, number 1, 2, and 3, I would go ahead and do that now. Otherwise, I'll wait about 5 seconds, then I will go through them. Okay, number 1, 6 to the negative 2 power. That's the same as 1 over 6 squared. Again, the negative exponent, it becomes a fraction, goes to the bottom, turns positive. Then 6 squared is 1 over 36. Next up, 5 to the negative 1 power. Again, negative exponent, can't have it. It goes to the bottom. 1 over 5 to the first is just 5. Okay, number 3 is a little bit different because we have a fraction in parentheses raised to a negative power. If you remember our exponent rules, this negative exponent goes to everything inside the exponents. So I have 1 to the negative 3 over 2 to the negative 3. This goes to the top, and this goes to the bottom. They both become positive when that happens. So I now have 2 to the third over 1 to the third. 2 to the third power, if you look at your perfects card, or 2 times 2 times 2 in your head, you should get 8 over 1, which is just 8. Okay, Now, let's apply this to logs a little bit. So first of all, you need to know how to read this. Oh, read the whole thing, not just part of it. This is read as log base b of a equals x, okay? You got to know how to say this, and it's very important, especially because this base part. Okay, so another way to rewrite this as is from log form to exponential is b to the x power equals a. I have this little shortcut highlighted down here. So it's the thing on the left, which is b, to the right power, b to the x power, equals the middle, equals a. B left to right equals middle. So for example, if I had, let's say, log base 3 of 9 equals 2, how would I rewrite that in exponential form? Left, the number on the left is 3. To the right power, the number on the right is 2. So 3 to the second power equals the middle number, 9. Okay, we can try one more like this. I'm going to erase the log base 3 of 9 equals 2. Let's do log base 5 of 1 over 25 equals -3. And what that means is left number on the left, the number on the left is 5. To the right power, my power on the right-hand side is -3. And that's going to equal the number in the middle. What's my number in the middle? 1 over 125. And that makes sense because like we just talked about, to get rid of a negative exponent, it goes to the bottom. So 5 to the -3 is 1 over 5 to the third. 5 to the third power, we get 125. So again, it's left to right power equals the number on the middle. We need to get really, 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 really good at rewriting these and going back between logarithmic form. Logarithmic form is this. This is logarithmic form. Let me write that down. And this, I understand it's kind of messy. I'm going to highlight it. I'm going to circle it in blue highlighter. This is exponential form. So again, logarithmic form is circled in black highlighter. Exponential form is circled in blue highlighter. Okay. So let's move on to some example problems. So it says rewrite in exponential form. So exponential form looks like this. Like I'll throw in numbers for you so it's easy. 5 squared equals 25. That's an example of exponential form. I have an exponent. Now, one thing I do want to talk about is exponents. So if I said, what's the exponent in the thing I'm about to circle in blue? What's the exponent here? You should say, oh, well, 2 is the exponent. It's 5 to the second power. But the point I want to make is what's the base? The base is this number. So it's 5 squared. The base is 5. Why is that important? Because again, if I am saying this in words, this is log base 7 of 49 equals 2. So my bases are actually the same. It's left to right power equals middle. So what's my number on the left? 7 to the right power squared equals the middle number. And that works out because 7 squared is 49. Okay, if you want, you can pause the video and watch the next two. Otherwise, I will go through them in about 5 seconds. Okay, here we go. Again, it's log base 1/3. That means 1/3 raised to the right power. What's the number on the right? -3 equals the number in the middle, which is 27. Left to the right power equals middle. And that makes sense, again, because if I actually went through and solved this, my numbers would distribute. I would get 3 to the positive 3 over 1 to the positive 3. 3 to the third is 27. 1 to the third is 1, would give me 27. Okay, now next up, number 3. Left to the right power equals 1. Or log base 52. That means my base is 52 to the first power is 52. And that makes sense because any number, the first number is itself. Okay, that is going from logarithmic form to exponential form. Personally, I think that's easier than going from exponential form to logarithmic form. So again, logarithmic form looks like log base, what did I say? Log base b of a equals x. And that is rewritten as, in exponential form, b to the x power equals a. Now, if you want to use numbers, that's fine as well. So if you want to write log base 3 of 9 equals 2, and then 3 squared equals 9, that's fine too. Either way you want to remember this, if you want to remember it like this or like this. If you want to use yellow or blue to kind of remember, if you want to use letters and numbers, that's fine. When I'm going from exponential to logarithmic, I like to write an example problem down because it's easier for me to just go back and forth in my head. Or another way you can do this is you can say, hey, which number is my base here? You should say, oh, well, 5 is my base, so it's log base 5 of 125 equals 3. Again, 5 to the third power equals 125. Left, my number on the left is 5. To the right power, to the third power, equals the middle number. 5 to the third is 125. Okay, again, if you want to pause the video and try number 2 and 3 on your own, that is fine. Otherwise, I'll take about 5 seconds and do them for you. Okay, so again, we need to write it as log base. So what's my base of this exponent? You should look at it and you should say, well, the base is 7. Log base 7. So, and again, it's left to right power equals middle. So my middle number should be 1 over 49 equals -2. Left to the right power equals the middle. Left to the right power equals the middle. 7 to the -2 power is 1 over 49. Okay, last up, number 3. First question you need to ask yourself is, what is the base? So my base is 17, so I'm going to say log base 17. And it's 17 to the 0 power equals 1. Left, my number on the left, to the right power equals the middle. So my middle number is going to be 1. My number on the right should be 0. Log base 17 of 1 equals 0. I believe that is all I have for you today. We're taking a whole day for this because it's very, very important for you to be able to go between the two forms. You need to go between logarithmic and an exponential form very quickly and very efficiently. If you're struggling with this, just shoot me an email. I can give you some more practice problems or find a YouTube video or two to help you. But again, it's very